Clothes dryers were invented in Europe in the early 1800s. The lady of the house would put the clothes in a metal barrel with holes in it, then turn it by hand over the fire. The first electric dryers were invented around 1915. Most of the parts are made from steel just 3/100 of an inch thick. The factory receives it from the supplier in giant rolls. They go onto a machine that cuts sheets about 3 feet long. Using those sheets, industrial presses stamp out various dryer parts. These are motor supports. And this is the back panel of the drum, the rotating compartment that holds the clothes. Note the small holes. We'll come back to them shortly. To form the side of the drum, the machine bends a sheet of pre-painted steel into a circular shape. When a clothes dryer operates, it sucks in outside air through a hole at the front. The air passes through the heating element and goes into the drum, entering through those little holes you saw a few moments ago located in the back panel. Once the automated machines have finished shaping the drum, they form a groove on its outside surface. This groove is for the motorized belt that drives the drum. Next, they put the drum on another machine that screws 3 baffles in place. Baffles are those thick plastic wings located inside the drum. They're what throw the clothes around as it rotates. Back on the automated line, the drum's front rim goes on. They manually assemble the drum's back panel. Then a machine installs it. Next comes the exhaust duct. Hot, moist air exits the drum through a series of holes and a large slot in the dryer door. The air gets channeled downward through the lint screen, then goes through a duct at the front of the dryer to the fan. The fan blows the air out this exhaust duct at the back of the dryer. The dryer's heating element works much like the element in a toaster, except it consumes a lot more power, up to 6,000 watts. The factory receives the steel and ceramic heating coils ready-made. Workers simply position them on a sheet of galvanized steel. They also install a temperature sensor that shuts off power should something go wrong and cause the dryer to overheat. In the finishing department, they coat the dryer with powdered paint that's heat and shock resistant. Then they assemble the bottom and back of the appliance. They install the motor that drives both the belt and the fan. Then the exhaust duct goes in. Automated machines prepare the electrical wiring. They paint and cut the wires. Then install a terminal on each end. Workers wire the dryers. Then install the drum. They close up the sides. Screw on the door, then wire up the control panel. It's connected to a series of gears and switches that control the dryer cycles. The model and serial number sticker marks the last stop on the assembly line. Sports like paintball are a pressure release in more ways than one. Paintball guns contain pressurized CO2 cartridges, and when the gas is released, the force propels the ammunition toward its target. The cartridges are also used for things like inflating bike tires and life preservers, as they target new uses for these pressure-filled devices. A CO2 cartridge packs a lot of punch into a little package. This one can propel dozens of shots. To make one, they unroll some steel and straighten it out. Then a punch press descends with 110 tons of force, cutting the steel into discs. Simultaneously, a machine moves up from below to shape the discs into cups. The cups move down a vibrating lane. They're delivered to a series of cylindrical punches, each one with a smaller diameter than the last. Each successive punch lengthens and narrows the cups as nozzles flush them with lubricant. The process is called redrawing, and at the end of it, the cups look more like test tubes. In just a few minutes, that piece of steel has undergone several transformations. To continue shaping the tubes, they heat the ends by dropping them through an induction coil. Intense magnetic fields excite the molecules in the metal, causing it to heat up sharply. This machine is called a necker. As it revolves, it delivers the tubes to a series of dies that pinch their ends. With each pinch, the ends get progressively smaller. This creates necks in the tubes. As the diameter of the neck narrows, the tube takes the shape of a bottle. Now, each cartridge goes on a lathe. A cutting tool plunge cuts the neck to shorten it. Then it carves out a lip, the same kind of lip that's on any beverage bottle. The cartridges now head through a washing station, where soap and water get rid of the oily lubricant. A trip under some gas burners dries them off, and they head to the filling station. Here, there's a tank full of carbon dioxide. The filling head pumps liquid CO2 into the cartridges and then caps them. Inside these cartridges, the gaseous form of CO2 is under great pressure. Releasing even just a little through a gun will be enough to propel things like BBs, pellets, and paintballs. They do spot checks to make sure the cartridges are tightly sealed. Now it's on to the next station, where they'll be made to look shiny and new. The cartridges are inside this revolving drum, which delivers an electrical charge attracting zinc from the tank to plate the cartridges. The smooth zinc plating doesn't just look good, it's a better surface to print information on. At this rotary silk screening station, the brand name and cautionary information are printed onto the sides of the cartridges. A quick bake under an ultraviolet light cures the ink. And these CO2 cartridges are now ready to demonstrate the power of compression.
The term collectible firearms refers to antique guns,
and top-of-the-line new guns made in the traditional style. These firearms are mostly handmade by skilled craftsmen using centuries-old techniques. This quality workmanship translates into top-notch performance. This company in England has been manufacturing rifles and shotguns since 1835. It still uses the same traditional gun-making methods, only now with the help of modern-day computerized equipment. Even with that technology, it's still arduous work. Making just one gun takes, depending on the model, up to 1,250 hours of labor. In the factory's machine shop, under a shower of lubricant, a computer-guided tooling machine shapes a solid steel bar into a hollow tube with a rectangular plate, called a lump, on one end. This tube will become the barrel of a shotgun. Here you can see the progression from bar to tube, but it's still somewhat rough. So now a highly skilled barrel maker manually files the tube to obtain exactly the right roundness. This traditional process is known as striking the barrel. With his expert eye, he checks his work by observing how light and shadows fall on the barrel. Now he lays two barrels side by side in a fixture and connects their lumps with pegs. He lays a strip of silver solder along the joint and binds the adjoined lumps with steel wire. Then he brushes on flux, a chemical which prevents steel from oxidizing and helps molten solder flow into the joint. He now loads this end of the pair of barrels into a small furnace. Within about 20 minutes, the fiery heat, peaking at a temperature of 1,650 degrees Fahrenheit, melts the silver solder, which flows into the joint. The barrels are now bonded. Next, he lays a thin strip of steel called a rib in the gap between the joined barrels. This time, he uses flux made of pine tree resin, which works better than chemical flux when soldering with tin. He immobilizes the rib with steel wedges and wire. Then, using a hand torch, melts tin solder to fix the rib between the barrels. After removing the wire and wedges, he cleans off the flux and excess tin with abrasive paper, revealing a seemingly seamless double barrel. Now he mounts the double barrel on a fixture and coats what's called a lapping rod with oil and an abrasive powder. He moves the rod back and forth within the barrels until their inside is ground to within a fraction of an inch of the required diameter. This process also smooths the interior of the bore to a mirror-like finish. The barrel maker then polishes the outside surface to a shine. Meanwhile, the action body, the part that houses the gun's mechanics, has already been roughly shaped. Now, the final machining in a bath of paraffin to wash away the metal debris. In a process called spark erosion, copper electrodes of varying shapes erode the steel to create the required slots, holes, and recesses. Quite the transformation from what started out as a solid piece of steel. It's critical that the action's 60-plus intricate components will fit together with ultimate precision. Once again, nothing beats the traditional method. The actioner blackens the component with a smoke lamp. Here, he's fitting the trigger plate. He positions it in the action, taps a few times, then removes it. The black soot marks left behind indicate where the plate needs to be filed down. He repeats this procedure again and again until the plate fits perfectly. He does this with each and every one of the action's components. Using the same marking method, he also files the lumps on the barrel to fit to the action perfectly. They hook onto a cross pin and serve as a hinge on which the barrel pivots against the action. He also marks and files the face of the barrel so that it fits perfectly with the face of the action. Such flawless precision is the hallmark of top-of-the-line firearms. The shotgun's action is finished. But there are still two main components to come. The lock is the firing mechanism. The stock is the gun's wooden butt end that you steady against your shoulder to shoot. Once those components join the others, the whole shotgun will be complete, lock, stock, and barrel. Some double-barreled shotguns have two triggers, one per barrel. Others have a single trigger which fires each barrel alternately. Depending on the style of the gun, the two barrels are positioned either side by side or one over the other. The gun's firing mechanism is called the lock. A double-barreled gun has two locks, one for each barrel. Each lock consists of a plate with 14 components. They've all been machined by the factory's computer-guided tooling equipment. An expert craftsman assembles them by hand. To test the lock, he uses a cocking key to simulate what happens when you pull the trigger. The key depresses two spring-loaded sears that release and drives a tumbler forward, striking a firing pin to fire the gun. The locks are installed on both sides of the action body, just above the trigger. In the factory stocking shop, another craftsman lays a template for the gun's stock onto a piece of Turkish walnut, traces, and then saws out the shape. The wood appears quite ordinary now, but wetting it a bit shows the rich grain which an extensive finishing later on will bring out. Just like the actioner before, he uses a smoke lamp to fit the action to the head of the stock, the soot marks telling him where to shave the wood with various chisels. This meticulous process takes more than 40 hours because he first has to strip the action of all its parts, then fit the main body into the stock, then reassemble the action piece by piece, fitting each and every one into the wood separately. Now, using a tool called a draw knife, he finalizes the stock's shape. By the time he finishes, the block of walnut has gone from this to this. A finishing specialist now applies linseed oil mixed with a hardener and polishes the wood many times over until the wood is lustrous. In the factory's engraving shop, decorative work is underway on each lock plate. An engraving artist first draws the design on paper, then on the plate in pencil. She then uses a sharp tool called a graver to cut the design into the metal plate. This process, while painstaking, requires minimal pressure. The graver is made of either high-speed steel or tungsten carbide, extremely hard metals which cut into steel quite easily. Later on, they'll highlight the engraving with black ink and varnish the surface to prevent tarnishing. Now, the action and lock plates undergo a heat treatment process that hardens the steel so that it won't wear out over time. This process leaves colors on the surface. On luxury guns like these, customers typically request designs or markings in gold inlay. After disassembling the barrels, the craftsman inlays, in this case, a barrel number. After cutting the number, he undercuts the edge of it so that the gold he then beats into the number will lock in place. Then he files the gold inlay flush with the surface and smooths off the excess with an abrasive stone. Every gun goes out to an independent authority for extensive firing tests. The gun returns certified with proof marks. The very last operation is a chemical treatment to protect the steel barrel from rusting. The steel reacts to this chemical process by turning from its natural silver color to black. Because these guns are not mass-produced, but handcrafted, with each and every component custom fit to the neighboring component, parts from one gun are never interchangeable with those of another, even if they're the same model. It takes approximately 1,000 working hours to produce a single gun, so customers placing an order typically wait at least a couple of years until delivery.
Colored pencils come in basic color packages for school children, upgraded sets for architects and other professionals, and elaborate collections of shades for the serious artist. It isn't so much the color variety that determines the quality, but the pigment concentration in the lead. The core of a colored pencil doesn't actually contain any lead. It's composed of pigments, minerals, and binding agents. This company invented a unique type of colored pencil. The lead composition is such that it allows you to brush on a bit of water after you draw to create the effect of watercolor paints. Colored pencils start with a combination of pigments. Every shade has a specific pigment recipe. They produce a large quantity of one shade at a time. Following that color's recipe, they meticulously weigh the different portions of ingredients. Then they boil a specific quantity of water and additives, and add binding agents, a secret blend of gums, resins, or waxes. The ingredients expand in hot water, forming a paste. Workers then mix the pigments into this paste. The next machine processes the paste into fine chunks, intensifying the color. The chunks move by conveyor belt with a cylinder that compresses them, then feeds them into an extrusion machine. The extruder squeezes the paste in a continuous stream. That's the diameter of the pencil lead. In a top-secret process, the next machine chops this long lead into pencil-length leads. But the leads can't write just yet. They're bathed in a vat filled with a mixture of chemical waxes. These waxes coat and impregnate the leads, in this case, red ones. Wax is a color delivery vehicle. As you write, it rubs off and adheres to the paper, taking pigment with it. With the leads now finished, the factory subjects random samples to quality control testing, including a break test and a durability test, in which each lead must yield 100 yards of writing. This company makes its pencil bodies from cedar wood. This machine carves grooves for the leads, then coats the surface with a thin layer of glue. The planks pass under a wheel that places the leads, then through another machine that slips a second groove plank on top. The next machine carves the hexagonal shape, then slices the pencils apart. One at a time, the pencils shoot through a vat of colored varnish. Their exterior is now the same color as the lead inside. Once the varnish dries, a heat stamp burns the company name and color number into the wood, filling the lettering with colored film. Then the pencils roll across an abrasive wheel, sharpening as they go. The unsharpened end gets a cap of varnish, either in white or the same shade as the pencil lead. The factory's equipment feeds the appropriate colors to the packaging area. As the pencils slide into their grooved tray, workers visually inspect each and every one. From pigments and planks to an artistic medium, the story behind the making of colored pencils is hardly black and white.